Hi, I'm gonna explain you today how to work with functions and how to operate them and how to find the inverse of a function. I hope you enjoy it. So let's start. First, functions, operations. Okay, for two functions fx and g of x, we have four operations. F plus g of x, f minus g of x, f times g of x, and f divided g of x. There's something called the composite function, and we call fx composed with gx. It's to change the x of f as g of x. And the domain of fx composed with gx is the set of all numbers x in the domain of gx such that gx is in the domain of fx. So imagine that we have three different sets. One set is x, the other set is g of x, and the other set is fx. X will be the first domain. This domain is going to be applied on gx to have the range of gx, but the range of gx, we're going to use it as the range of, as the domain of fx. So the range of fx, the composite function, the range is given by the range of gx. That will be the domain of fx. That's the composite function. And we're going to watch it in an example. We're going to see the operations and the composite functions with an example before talking about the inverse. So we have the functions fx equals 3x squared minus 5 and gx equals x minus 3. So let's calculate the addition. So the addition is f plus g of x is just the addition. So 3x squared minus 5 plus x minus 3. X minus 3. Remember to organize the terms to have the function in a standard form. So for example, minus 5 minus 3 is minus 8. So we have here a quadratic equation. This is the addition. Now let's write the subtraction. F minus g of x, so it's fx minus gx Now we're going to subtract it. So 3x squared minus 5 negative, remember to change the sign, so negative x plus 3. If you multiply, minus x minus times minus 3 is positive 3. So we have 3x squared minus 5 minus x plus 3. And if you simplify it, minus 5 plus 3 is minus 2. So we have two different functions. The addition is different than the subtraction. Now, what about the multiplication? Multiplication. What about the multiplication? So multiplied f g multiplied, so it's the multiplication. And here we can apply FOIL. 3x squared times x is 3x to the third power. 3x squared times minus 3 minus 9x squared. X squared. Minus 5 times x minus 5x minus 5 times minus 3 positive 15. So this is the function that represents the multiplication. The multiplication. It's a cubic polynomial, okay? A third-degree polynomial. And division. So the division is f divided g of x equals to three x squared minus 5 divided x minus 3. You can remember the synthetic division to apply it, because we have to form x minus 3 to have the polynomial. Apply synthetic division. If you want to apply long division, so there's no problem. There's no problem to apply synthetic division. So we have here three and 2 1 0 4. Okay, so A is 3. A is 3, and dividend is to the second power, so 3 0 5, and here I'm going to write the solution. So synthetic division, move the first down, multiply 3 times 3, 9, add, so we have 9, multiply 9 times 3 is 27, add 27 plus 5 is 32. So this is one way to write the polynomial. The remainder is not 0, so you can choose to write the polynomial as the division of both, or we can write it using the expression of the division, that is remainder that it's quotient. The quotient here will be 3x plus 9 plus remainder 32 divided divisor. You can write it using this, but we can use both this or this. You use synthetic division to check that there are the remainder is not 0, so you don't have factors here. But you can apply anything you want. And this is division. Now composite function. We're going to find the composite function. The composite function. Okay, the composite function will be fx, which one is fx? 3x squared minus 5. 3x squared minus 5. But f composed with g means that instead of x, I'm going to use g of x. So g of x is x minus 3. So instead of x, I'm going to use g, that is x minus 3. Now let me simplify it. This is a perfect square trinomial, so we have 3 factor of x to the second power minus 3 times 2, 6x plus 9 minus 5. And let me simplify the parentheses. 3x squared minus 6x, 6 times 3, 18x, plus 3 times 9, 27, minus 5. And we just have to simplify our answer. 3x squared minus 18x, 27 minus 5 is 22. 22. So this is the f composed g. F composed g. Some people would ask, g composed with f. Yes, of course, you just have to change x here by 3x squared minus 5. And this is how you operate functions and you find the composite function. It's just a little bit of algebra. And now to find the inverse. Now let me tell you how you can find the inverse. Finding the inverse of a function. First, set the domain in which the function is 1 to 1. I mean, a function is 1 to 1 if one element of the domain just give you one element of the range. No more. You couldn't have more than one element of the range from the domain. And then change fx for y, interchange the variables x and y. If it is possible, solve the equation for y in terms of x to find f, the inverse of x, and check the result. Okay, maybe you don't understand the steps. We're going to apply. Find the inverse of the following function. Fx equals x minus 2 to the second power, and x is greater than or equals to 2. Why x should be greater than or equals than 2? Equals to 2, because if not, the function is not one-to-one. Let me show you why. Let me show you why. I'm going to do a graph of x and fx. So -2, -1, 0, 1, and 2. So this is x minus 2 to the second power, and as you could see, 3, 4, 5, and 6. As you could see, we are getting 1 in the range for using two numbers, 1 and 3. So it's not a one-to-one function. To be a one-to-one function, you need that just one element of the domain, I mean 3, gives you one element of the range. Here you have two elements of the domain, 1 and 3, or 0 and 4, that is giving you the same element of the range, 4. So that's why we choose greater than 2, greater than or equals to 2, because then we just have a one-to-one function. One-to-one function. Something interesting about this function. If I graph the function, it has a symmetry according to 2 in x. It's the same. Okay? To set it one-to-one, you need to start with 2. That's why here we're telling that the function is greater than 2. Otherwise, we couldn't find the inverse. To find the inverse, you should set the domain in which the function is one-to-one. Now, we're going to change fx for y. Y equals to x minus 2 to the second power. First step. Now, interchange the variables x and y. So, interchange x and y. We can interchange again because the function is one-to-one. Otherwise, we couldn't do it. Now we interchange. Now, if it is possible, solve the equation for y in terms of x. So I'm going to apply the square root method. So to solve this equation, I have a square here. So I'm going to apply the square root to each side. Apply the square root to each side of the equation. So here we have the square root. Usually we have to write here positive or negative square root, but we're using x greater than or equals to 2. So it means that there's no way that x will be negative. It means that y couldn't be negative. So to be sure that y is not negative, we're just going to use the positive members. Now we have to solve for y. So we just have to add to each side of the equation 2. to have y square root of x plus 2. Square root of x plus 2. This is y. So we solve the equation for y in terms of x to find the inverse. So we found the inverse. We found the inverse. The inverse is just the square root of x plus 2. Square root of x plus 2. And now we have to check the result. I mean, f composed with the inverse of f should be x. Let's try it. So remember, checking. To check, we have to apply the composite function. So instead of x, we're going to use the inverse of x. The inverse of x. Instead of x, we have to use the inverse of x. The inverse of x. So we have square root of positive 2 plus 2 minus 2. This is 0. So we have the square root of x to the second power. This is x. So yes, it is the inverse. If you notice, if we used the negative square root of x, we can have x as well. But we're not using this domain. We're using the other domain, x less than or equals to 2. So knowing how to find the inverse is knowing how to apply the composite function. This is how the operation of functions works, and this is how the inverse of a function is calculated. So I hope that you enjoyed the video. Any question, please let me know. Any hint, also let me know. And I hope that you enjoyed the video. Goodbye.